All right, y'all, section 4.3, all about elimination. Okay, we did substitution yesterday. Today we're going to do elimination, and elimination is exactly what it sounds like. You're going to eliminate a variable. And a lot of times it's because it's in ax plus by equals c form. Okay, this is also called the addition method. It says sometimes called it, that's what we call it, as elimination. A lot of times, if you just remember, if you can look at it and you can just add down right away and stuff cancels, then you can just add down and do that. And so they're kind of trying to tell you this here on the next step. You're looking for things that can cancel, right? So it keeps going here and it just deletes those because y minus y is 0, x plus x is 1x plus 1x is 2x, and negative 2 plus negative 6 is negative 8. And then they get to here and they just divide it. They found x equals negative 4, and guess what? Of course, you just go back and plug it in. They plugged it into the first one. It doesn't really matter which one you do it in. They did the opposite of this to both sides by adding 4 over there, and then they get y equals 2. And hence the answer is negative 4, 2. And you can always check these just kind of in your head, right? So they got negative 4, 2. Negative 4 plus 2 is negative 2. Negative 4 minus 2 is negative 6. It works, right? So let's go do skill practice number 1 using the same thing. Okay, we've got we've got a problem that's just set up right away for us, right? These will cancel if I just add down. So 1x plus 2x is 3x equals, well, 15. And of course I would divide there to get x equals 3. And I would go back and I say, well, I could plug it in here and go 2 times 3 is 6 and bring it to the other side, but I think it's just easier to just do it into this one, right? And we can see from there that to solve for y, you would just minus 3 to both sides, and you get y equals 10, right? So, did I just do that wrong? I feel like I did. Oh, jeez. Because 15 divided by 3 is 5. 5, not 3. I'm sure some of you are already saying that. I'm not even going to restart this. I don't even care. Let's just plug 5 in there instead. I would still minus 5 to both sides, and I would get 8. And so I get the answer of 5, 8. And if I had 3, 10, right, 3 plus 10 is 13. But 6 minus 10 is not 2. That's why I knew I did something wrong before I even went into it, right? But if I go 5 plus 8 is 13, and 10, because of 2 times 5, minus 8, well, that's 2. It works. Cool. Let's move on. Okay, on the next page, it has the procedure. Really, this is a long way of saying, first get them in this form so you can just cancel out a term, right? Then if you have decimals or fractions, clear them out. We'll worry about that in a couple more problems, but you'll see that, and we've seen that something similar to that before. Then you're going to multiply either one or both of the equations by a number to find opposites, right? The opposite of 3 is negative 3. The opposite of negative 1 is 1, and so on, right? Then you'll just add the equations down. Do not subtract unless you have like 5 plus negative 4, okay? Solve for the remaining variable, and then substitute that back in to find it. And then they say check. Well, am I going to count check? Well, unless it says check, no, I'm not, okay? Let's look at skill practice number 2. Actually, let's continue, sorry, with example number 2 here. Okay, and on example number 2, it is giving you an equation, and we could do it one of 2 ways. Either I could times, I want to look for maybe something that 3x and 2x go into, which is 6x. So I could times this line by negative 2 and times this line by 3, so that I have a negative 6 and a positive 6, but then I have to do it to every single term. What they did is they saw a minus sign here and a plus sign here and thought, well, those are already working on opposites, right? As long as I times this by 5, this whole equation by 5, I'll get a negative 5y. I'm not worried about anything else. I want a negative 5 and a positive 5 to cancel. And as you can see, that's what they did here. They multiplied by 5. They got the negative 5 and the positive 5 to cancel here. Added down. 17 plus negative 30 is negative 13. Of course, divided to get negative 1, and just like everything else. Plugged it back in and went for it, right? So let's go to skill practice number 2 here. And I can see that if I times this line by negative 4, I'm going to get negative 4x to cancel with that. So I'm going to rewrite it over here. 4x plus 3y equals 3. Negative 4x, positive 8y, because a negative 4 times a negative, remember, you're still distributing here, equals negative 36. Okay, those will cancel. 11y equals negative 33. And of course, you would divide both of these by 11. I just realized you couldn't see any of that. Man, I am all over the place right now. All right, let me try this again. I was looking for opposites here. I used -4. I multiplied -4 through every term to get here. -4x plus 8y equals -36. I saw my opposites to cancel. I needed that, right? And I just added down and added down. Then, of course, I divide like everything else. Y equals -3. And I'm going to go back and plug that into either one of these y's. I don't care which one. You have to get the same thing either way, or you did something wrong. Let's just plug it into the first one, just because it's the first one. Right? 4x minus 9 equals 3. I would add 9 to both sides to get there, and I would divide by 4 to get x equals 3. And there's my answer, 3, -3. Let me go back and check here. 12 minus 9, 3. 3, negative, make that plus 6 is 9. It works. Okay. Alrighty, so on the next problem in the book, okay, under example number 3, so as I'm doing this, this is kind of like how you would be doing your reading assignments, right? You would say, let's look at what example 3 is doing, and then let's use it to do skill practice 3. So I've got an equation here that they're showing me, right? They're showing me this here, and it's got a b on one side and a on the other side, whereas it has a and b here. Well, if you remember back in the procedures page, it said to move it over to get it into ax plus by equals c form. So I want to move that a over to this side so that then I can compare them. So that's what it's doing here first, right? It's taking this, it's minusing 7a to both sides, canceling here, and you get to there. Now you can write them above each other. But as you can see here, there's kind of opposites here, but there's nothing I can multiply 2 by to get 5. So what they did here is they got it in this way, and I look at the opposites and say, man, if that's times 2, it's 10. If that's times 5, it's -10. And then I've got my opposites to cancel like I want. And that's what they did here. They multiplied both lines, this one by 2 and this one by 5, to get the 10s that they can cancel, added down, divided, of course, and then plugged it back in, just like everything else. I keep saying the same thing over and over, right? All right, so let's check out skill practice number 3 then. Yep, now you can see it. I should have looked up the first time. Alright, so again, not in the right order. But if I add 5m to both sides, then those cancel, and I get 5m plus 8n equals 4. And I get, well, this other one didn't change, 7m plus 6n equals -10. I feel like I might run out of space here, so I'm trying to keep it a little bit helpful here. Now, I can do one of two things here. 5 and 7 go into 35, so I can multiply 7 and 5 and make one of them negative and go. Or 8 and 6 gives me 48. But also, what else would 8 and 6 go into? Right? Think about that for a second. 24, right? Like 8 times 3 and 6 times 4. Now here's the thing. One of them has to be negative to get opposites here because everything is positive, 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 positive. Right? So it doesn't matter if you put it on the top one or the bottom one. I've already done it once on the bottom one on number 2, so I'm just going to do it on the top. -3 here, distributed in, gives me -15m minus 24n equals -12. 4 times 7 is 28m plus 24n equals 40. -40, excuse me. That's going to be a big difference if I don't have a negative sign there. Alright, these cancel. I can add down here. I get 13m equals -52, because -12 plus -40 is -52. And when you divide, it happens to work out kind of nice. The m is -4. Okay, and I just go back and plug that in. It doesn't really matter, again, if I plug it in here or here. It's just kind of a pain here with everything that, if I just do that. Well, no, actually, let's try it. Right, 8n equals 4 minus 5 times -4. So 8n equals, well, this would be 20 plus 4, that's 24. And I just divide to get n equals 3. And when you write points, you write the first letter like x and y as m and n, you'd write the same way. So -4, comma, 3. If I would have plugged it in here, right, I would have had, again, m to be -4. So I would have had 7 times -4 plus 6n. Yep, you can see that, equals -10. This would be -28. I would add it to both sides and get 6n equals 18, and when I divide, I'd still get 3. So there's just kind of proof that you can plug it into either equation and still get there. Okay. All right, well, I better make sure actually that this works. So n is 3, so that would be 24. And 4 minus negative, or let's see, that would be negative positive 20 plus 4 is 24 equals 24. Good. And m is negative 4 here would be negative 28 plus 18. Yep, that equals negative 10. It checks. Good to go. Okay. All right. Then we start getting into some weird answers, right? So what they do in example 4, and this is kind of a big deal actually, is they get an equation, big numbers, right? And they say, okay, the first thing I want to do is I want to times this bottom line by negative 2. Because if I do that, then look, the x's will cancel. I'll get some crazy y numbers here. And then I want you to reduce this fraction. Okay, reduce this fraction. Now, with that being said, what goes into both of those? Well, 2 goes into both of those, 21 and 77 times. And then I say, oh, 7 goes into both of those, and that's how they get there. Okay. All right, so from there, and it says it here, to find the value of x, we normally substitute that in, right? But if I substitute 3/11ths in right there, that's going to get gross, right? And it is there too. It's not impossible, right? But what they're saying is, why don't you go back to the original problem and solve it for x. So instead of multiplying this number, if I would have multiplied that number or that number to get stuff to cancel, which obviously that times 4 gives me that. So I just multiply that by negative 4, which is what they did. Right, they're multiplied by negative 4. The 88y's will cancel. They combine like terms here, and they get another ugly fraction. Now here's the thing. If I would have plugged in 3/11ths into either of these spots, it wouldn't have been terrible, right? I would have got 34x minus, now let me show this work over here, 22 over 1 times 3 over 11 would cancel, right? I get 66 over 11, which is 6. And that's not terrible, right? I'd get that and then equals 4. I'd add it to the other side to get 34x equals 10. And I would divide to get 10 over 34, which guess what? Reduces to 5 over 17, which is what the book has as an answer anyway. Okay? So, with that being said, oh, you can't even see that right now, but you can see it in the book, right? Okay? Alright, so let's go and do an ugly one for us. Okay, number 4 here. It does have fractions in our answer. We'll get to that. Alright, so the first things first, I'm going to look and see, well, if I times this by negative 3, I'm going to get a negative 45 here. That'll cancel, right? So I'm going to get negative 45x plus 48y equals negative 3. Okay. And, make sure you can see this. Alright. And the bottom line didn't change. And these cancel. 52y equals 13, and I would divide by 52, and I'm here to tell you that 13 goes in there exactly 4 times, so here I get y equals 1/4. Okay. For the x, again, I can plug 1/4 into either one of these and solve it from there, but maybe I just go back and look at the original problem. If I look at those two numbers, if I times this by 4, 16 and negative 16 will cancel, right? So I'm going to write that times 4 and write that down here. So I've got 15x minus 16y equals 1. I've got 4 times 45 is 180 plus 16y equals 64. These will cancel. I get 195 equals, well, 65. Excuse me, 195x equals 65, and I would divide by 195. And again, you probably say to yourself, I don't know how to reduce that, but you can reduce by 5, right? 5 goes into 50 10 times, so that's 13 on top. 5 goes into 240 times, so 5 less would make it 39. And now 13 goes into both of those, so that's 1 and 3. So the point is 1/3 for my x and 1/4 for my y. Okay. All right. So let's keep going here. Skill practice number 5. As you look in the book to clear out fractions, okay, what they're trying to do here is whenever you see the common denominator, and this is the same thing we did yesterday, whatever the common denominator is, times everything by it. So in this case, it's 4, right? And 4 times 1/2 is 2. And 4 times 5/4, remember we put that over 1 and we multiply tops to tops and bottoms to bottoms, and I get 20 over 4, which is 5. 20 divided by 4 is 5. And of course, on this side, I went 4 times 1, that's how I got 4 as well. and then they just put them above each other and went from there to solving it. Okay, so in this problem, it's a no solution because you get, again, two numbers that do not equal each other. If they are equal, it's IMS. If they are not equal, it is no solution. And so I look at number 5 and number 6 because really it's kind of the same thing. Here I'm going to get rid of this fraction by timesing everything by the denominator of 12. Again, because 3 and 4 both go into 12. Right? I don't want to use 6 because 4 doesn't go into that. Because if I think about, again, 2/3 times 12 over 1, I get 24 over 3, and 24 over 3 is 8x. When I distribute it in here, okay, I'm going to get 3/4 times 12 over 1, and 36 divided by 4. Gotta keep doing that. You guys can't see that again. So the first one I did is 12 times 2/3 right here. 12 over 1 times 2/3, 24 over 3 is how I got 8x. Right here, when I do 12 times 3/4, I put 12 over 1 to get 36 over 4, which is 9y. And then 12 times 2, of course, is 24. Compared to 8x minus 9y equals 6. You can probably see what's going on here, but what I'm going to do here is I'm going to times this line by -1, right? Because if I do that, then I'll get my 8x to be negative. That's what I want. I'm going to write it down here. Negative 8x plus 9y equals negative 24. And again, you see these cancel. 0 equals negative 18, and 0 will never equal 18 or negative 18 or any other number but 0. And so this is no solution. You might remember you can put that as well. Okay. All right. So on this one, kind of similar to the problem that we did up above, number 3, right, where we had to first move the m over. So I want to get x and y on the same side. So I'm going to minus 3y to both sides. Okay, you could see the example in the book that does something very similar to this. And what they're trying to do, let's see, 3x minus 3y equals 15. And 2x minus 2y equals 10. And so again here I say, what can I put 3 and 2 into? And that's 6. So I'm going to times this line by 2 and times this line by 3. But again, one of them has to be negative. Earlier I chose the top one, so I'm just going to do the bottom one on this one. And when I go to multiply that through the top one, I get 6x minus 6y equals 30. The bottom one, I get negative 6x plus 6y equals negative 30. And look what happens. Cancel, cancel 0, cancel 0, and 0 does equal 0. Always, always, always 0 will equal 0. And so what that means is IMS. So basically, these are the same exact line. And it basically, on this one, they were parallel. On the other one before it, that's why there was no solution. Because they are parallel lines, and here it's because they are the same line. They go over each other. Okay. All right. So I think that is it. Oh no, I take that back. We've got this concept connections question, which is going to kind of show up on a test for you. So I thought maybe I'd at least visit it. Let me zoom in a little bit more here. You can see it obviously right on your book. But in a system of two linear equations, if one equation is in slope-intercept form, think of what that means. If it's in slope-intercept form, that means it's in y equals mx plus b, right? Which method of solving would you most likely be the best choice, right? Would you use elimination or substitution? And really, if something is solved for a single variable, let's say I have 3x plus 4y equals 5, then I have y equals 3x minus 4, well, I would want to take this and I would want to plug it in right there. Now, could I bring the 3x over as a negative 3x and use elimination? Yes, but if it's already solved for a variable by itself, you should probably just use substitution. And that's what it's trying to say down at the very bottom. The variable is already isolated, like it's already y solved for. Therefore, substitution would most likely be the best choice, right? Because the variable is already solved for. Okay. Just kind of keep that in mind. I know not a whole lot of you watch everything in this video. For those of you who did hear that, it's going to be a bit of an advantage for you on the next test. All right, so almost done here. Just write down the homework here, which is homework page 322 to 324, numbers 6 through 9, 11, 21, 27 through 39 odd, and number 64. And just as a reminder, your final draft of your project paper is due tomorrow. Have a good day.